Hi, I have a story I want to tell you guys. One day, I saw a group of girls want to stir the two solutions. So there is two conditions.
Scene 1. From here we can see that three girls are having difficulty to stir the eggs liquid. Meanwhile, in scene 2, these three girls are having no difficulty at all to stir the white liquid.
X is more difficult to stir than Y.
The question here is what is viscous and what is concentration. Firstly, viscosity is a measure of a fluid resistant to flow. If viscosity increase, the more harder to stir. Next, the concentration refer to the amount of a substance per defined space. The higher concentration, the harder to stir. The relationship between viscous and concentration is directly proportional.
Surface tension. Surface tension is the elastic tendency of a fluid surface which makes it acquire the least surface area possible. At liquid air interfaces, surface tension results from the greater attraction of liquid molecules to each other due to cohesion than the molecules in the air due to addition. The vapor pressure for small droplets of liquid in suspension is greater than standard vapor pressure of that same liquid when the interface is flat. The general trend is that surface tension decreases when the increase of temperature reaching at a value of 0 at the critical temperature.
Next, viscosity. Viscosity is resistance of a fluid to flow and it results from intermolecular attractions that impede the movement of molecules around and past each other. The higher temperature, the lower viscosity. It is because molecules moving more faster to overcome intermolecular forces, resistance to flow decrease. Molecular shape. Small spherical molecules make little contact and pull easily. Same intermolecular force, liquids consisting of longer molecules have higher viscosities.
Two types of electrostatic force. First, intermolecular force are forces that hold two molecules together. London dispersion force, also called van der Waals force, acts on all molecules and are the only force between two non-polar molecules. Two polar molecules are held together by the electrostatic attraction between their dipoles in dipole-dipole force. The strongest type of intermolecular force is hydrogen bonding. Intramolecular force is within a compound which are ionic, covalent and metallic.
The first type of intermolecular forces, hydrogen bond.
Between atom hydrogen and nitrogen, oxygen and fluorine.
The strongest attraction because hydrogen is very electropositive.
The molecules are very polar molecules.
Example, hydrogen fluoride is more polar than hydrogen chloride because of the degree of polarity.
Has high boiling point because more energy need to break the hydrogen bond between molecules.
Dipole-dipole force. Attraction between opposite charge region, partial positive charge of molecules, of interact with negatively charged of neighboring molecules. Example, hydrogen chloride. Polar molecules but not as polar as hydrogen fluoride. Hydrogen chloride has a high boiling but lower than hydrogen fluoride.
London dispersion forces. Both hydrogen chloride and hydrogen fluoride have the London dispersion forces. However, the forces is negated because the hydrogen bond and the dipole-dipole force is much more significant. Intermolecular forces affect boiling point. Molecules with stronger intermolecular forces have higher boiling point. A high temperature gives the molecules enough kinetic energy to break away from their neighbors. They can escape into gas phase. Liquids with weak intermolecular attraction to each other, their molecules can escape into the gas phase with ease. That means their boiling points are lower. Liquid with higher intermolecular forces need more energy to overcome these attractions. The temperature and boiling point are higher, so a substance that contains hydrogen bonding will have a far greater boiling point than one which contains London dispersion forces.
Next, vaporization versus evaporation. Vaporization is a conversion of a substance from liquid or solid phase into the gaseous vapor phase. Occurs at the boiling point, take place at the boiling point. The rate of vaporization is independent of the surface area of the liquid, wind speed, humidity, and the temperature. Okay, next, evaporation. Evaporation is a type of vaporization of liquid to gaseous phase. Occurs below the boiling point. Take place at any temperature. Next, the rate of evaporation depends on the surface area of the liquid, speed of wind, humidity, and the temperature.
Next, the definitions of boiling point, vapor pressure, and the relationship between vapor pressure and boiling point. Boiling is a phase transition from the liquid state to the gas state. The boiling point is the temperature at which the vapor pressure of a liquid equals the external pressure surrounding the liquid. The vapor pressure of a liquid is the equilibrium pressure of a vapor above its liquid. The boiling point of ethanol is 78.37 Celsius, while for the butane is -1 Celsius. The relationship between of vapor pressure and boiling point is the boiling point decreases as the vapor pressure increases, because if the intermolecular forces are small, the liquid has a high vapor pressure.